Imagine a place so vast it could swallow nearly the entire United States. This is the Sahara. It's not just a desert. It's a planetary-scale engine, a furnace of heat and wind that shapes the lives of billions. The Sahara is a climate powerhouse whose influence reaches far beyond Africa. Its story is written in the sky, in the oceans, and in the very air we breathe. This colossal expanse acts like a giant solar panel, heating up under relentless sun and creating a massive dome of hot, dry air, the Saharan high-pressure system. This system pushes away rain clouds, ensuring the Sahara remains one of the driest places on Earth. The heat rising from the Sahara creates powerful winds that travel thousands of miles, carrying with them the desert's signature heat and dryness and billions of tons of dust. This atmospheric river of particles connects the Sahara to ecosystems as far away as the Caribbean and South America. The Sahara is a critical node in a complex global network, a testament to the interconnectedness of our planet's systems. When we look at this sea of sand, we're witnessing the heart of a powerful climate machine. Its energy radiates outward, shaping weather patterns, influencing ocean currents, and even fertilizing distant rainforests. The Sahara is a dynamic, ever-changing character in the grand drama of our planet's climate. Its story is one of immense scale, a single region holding the entire planet in its sway. Africa's seasons are set by the Sahara. The continent's rainy and dry seasons are a direct result of the desert's immense atmospheric influence. The key is the Intertropical Convergence Zone, or ITCZ, a band of clouds and storms near the equator. The Sahara's high-pressure system choreographs the ITCZ's annual migration north and south. In summer, the Sahara heats up, pulling the ITCZ northward and unleashing monsoons across the Sahel. The desert paradoxically brings life-sustaining water to millions. When the seasons shift, the Sahara cools, its high-pressure system weakens, and the ITCZ retreats south, ending the rains. The dry Harmattan winds blow from the desert, turning skies hazy and the air arid. This cycle is the heartbeat of West and Central Africa, dictating when to plant, when rivers flood, and when to endure hardship. The Sahara isn't just a bystander, it's the lead actor in this climatic drama. Its existence creates the dramatic swing between deluge and drought. Even the most barren places play a vital role in the dance of the elements. Each year the Sahara launches a spectacular mission into the sky dust. Winds lift hundreds of millions of tons of fine mineral particles, forming the Saharan air layer, a massive dusty river in the atmosphere. This layer travels west across the Atlantic, connecting Africa to the Americas. As it moves, the Saharan air layer suppresses hurricanes by bringing dry air and strong winds that disrupt storm formation. In years with strong dust outbreaks, Atlantic hurricane seasons are often less active. The desert, from thousands of miles away, protects coastlines by strangling storms before they grow. But the dust's journey doesn't end there. When it reaches the Amazon, it delivers vital nutrients, especially phosphorus, replenishing the rainforest's soil. The Sahara, a symbol of barrenness, is essential for the health of the planet's greatest rainforest. Scientists track these dust plumes by satellite, studying their impact on weather, air quality, and ecosystems. Recent years have seen record-breaking dust events, raising questions about how climate change might alter this cycle. Will a warmer world mean a dustier Sahara? The answer could reshape hurricane seasons and the fate of the Amazon. The Sahara's dusty breath is a powerful climate variable, one we're only beginning to understand. The Sahara wasn't always a desert. 11,000 years ago it was a land of grasslands, lakes and rivers, a green Sahara teeming with life. Satellite images reveal ancient riverbeds and the outlines of massive paleo-lakes like Lake Mega Chad. Rock art in remote mountains depicts elephants, hippos, and thriving human communities. This transformation was driven by subtle changes in Earth's orbit, which shifted the monsoon northward and brought rains to the Sahara. For thousands of years, the desert bloomed, supporting wildlife and early human societies. Archaeologists have found evidence of pastoral communities and migration routes across this lush corridor. The Sahara was a bridge, not a barrier, for early humans spreading out of Africa. Its greening opened doors for exploration and the rise of civilizations. The memory of this green world reminds us that climate is never static. Even the most formidable landscapes can change dramatically. The green Sahara's paradise didn't last. Around 6,000 years ago, Earth's orbit shifted again, weakening the monsoon and drying the land. Lakes shrank, rivers vanished, and grasslands gave way to sand. For years, scientists thought this was a slow natural process. but new evidence suggests the desert's return may have been abrupt, possibly accelerated by humans. Early herders, concentrated around shrinking water sources, may have overgrazed the land, stripping away vegetation. Bare soil reflects more sunlight, which could have further suppressed rainfall and sped up desertification. This early anthropogenic hypothesis suggests humans nudged the Sahara past a tipping point. The science is still debated, but it raises a profound question. Did humanity help create the world's largest hot desert? Even small changes on the ground can have massive consequences in the sky. Today, the Sahara is on the move again, this time, driven by human-caused climate change. The desert's southern edge has expanded by about 10% since 1920, threatening millions in the Sahel. As the desert advances, rainfall becomes erratic, pastures degrade and harvests fail, forcing people to migrate or face hardship. The Sahara's expansion is a slow-motion human tragedy, a stark example of climate's impact on vulnerable communities. Yet the story isn't just one of relentless expansion. Recent satellite data reveal that parts of the Sahara and Sahel are actually becoming greener. This greening of the Sahel is linked to changing land use and, paradoxically, rising global temperatures, shifting monsoon patterns. Some areas are seeing more rain and vegetation, offering a glimmer of hope. Scientists are working to understand if this greening is temporary or a long-term trend. The Sahara's response to climate change is complex. Some regions suffer, others benefit. It's a landscape of both destruction and renewal. The desert continues to surprise us. Confronted by the Sahara's power, some scientists dream of geoengineering reshaping the desert itself. One bold idea: build vast solar and wind farms across the Sahara. These installations could generate massive clean energy, and by altering heat and airflow, potentially increase rainfall and green the desert. Models suggest this could double local rainfall, boost agriculture, and turn the Sahara into a hub of renewable power. But the risks are huge. Changing the Sahara's climate could have unintended consequences, shifting rainfall away from the Amazon or altering hurricane tracks. We'd be pulling a giant lever on the global climate machine with unpredictable results. The Sahara embodies our relationship with the planet, a source of danger and life, memory and mystery. Its dust fertilizes rainforests, its past holds the memory of a green world. The future of the Sahara is one of the great unanswered questions of our time. Will it keep expanding, or could it bloom again through nature's feedbacks or our own interventions? As we enter a new climatic era, the Sahara holds both a warning and a whisper of hope.